Hi everyone, welcome back. This is section 4.4 of my calculus class, the fundamental theorem of calculus. So we're finally at the point where we integrate and we'll be able to find the actual area using the fundamental theorem of calculus. Now, it states right here that if a function is continuous on a closed interval from a to b, and capital F is the antiderivative of lowercase f, then this is your fundamental theorem of calculus formula right here. Now, what does this mean? This means you're going to integrate and then plug in the upper bound, subtract it from plugging in the lower bound. So the best way I can start off with this is talking about the example that was on our last quiz that we did by geometry. So knowing that this is the origin right here, and we have the integral from 1 to 4 of just 5 dx. Now we know that 5, 1, 2, 3, 4, 5, is just a horizontal line. And we are bounding this from 1 to 4. 2, 3, 4 right there. Okay. 1, 2, 3, 4. Alright, so what I want to do here is figure out that this area this area right here is going to be, as you can see here, a 3 by 5 rectangle. And we know that that area is going to be 15. Now, if I apply the fundamental theorem of calculus to this integral, look what happens. I've got the integral from 1 to 4 of 5 dx. And if I integrate this, I know I'm going to have 5x. So now what the fundamental theorem of calculus says here now is if I take the bounds, and this is just the notation we use here, going from 1 to 4, and I plug in the top one minus the bottom one, I'll see that I get 20 minus 5, and I get 15. There's my area. So we no longer have to rely on geometric shapes in order to do that. So you integrate, power rule, everything you've learned up to this point, and now you start off by substitution here of doing the upper bound minus the lower bound. So let's take a look at a few examples here and we'll motor through. Not real difficult. Here we've got the next one, the integral from 1 to 3 of x squared minus 3 dx. So if I apply the power rule that I know I raise the power by 1, divide by new power. So I'll have 1/3 x cubed minus 3x. And I'm going to do this from 1 to 3. And it's always top one minus the bottom one. So when I do this, I'll have 1/3 3 cubed minus 3 times 3. And this whole thing minus the bottom. So I plug in 1, so I'll have 1/3 1 cubed minus 3 times 1. And now I can either, figure this out on my calculator or just, figure out that's 27. 27 divided by 3 is 9. There we got all that stuff, and we wind up with, this will be 0 minus a negative 8/3, which is a positive 8/3. So there is the area under the curve of x squared plus 3. Now just kind of a quick visual, x squared minus 3, that's just a parabola here, and we're bounded between 1 and 3. So wherever that area, falls in between there, we have 8/3 that's going to be there. Okay? Let's look at another one. I got the integral going from 0 to 4 now. Okay? 0 to 4 of 3x squared plus 2x minus 4. So again, power rule. This is going to be x cubed, raise power by 1, divide by new power, the 3's will cancel, plus x squared, same thing, minus 4x. And this is a definite integral now because we're definitely getting an area here, so no plus c's, remember, and we're going from 0 to 4. So I know, again, putting the first one in, I'm going to have 4 cubed plus 4 squared minus 4 times 4, and that whole thing subtracted from putting in 0. So I got 0 cubed plus 0 squared minus 4 times 0, so this is nicely going to be 0 right here. And then when I look, and again, go into your calculator or whatever, you're going to have with 4 cubed plus 4 squared and then minus the 16 there, this is going to actually wind up being 64. So 64 is your answer for that one. Okay, so keep moving here, a few more examples. I got one right here where we're going to have to make sure we change this so that we can apply the power rule. 1 to 4, 3x to the 1/2. Okay, so when I do this, I know I got the 3. All right, raise the power by 1, so that's x to the 3/2. Dividing by 3/2 is the same as multiplying by 2/3. So as you can see here, the 3's will cancel. So we'll wind up with 2x to the 3/2, and this is going from 1 to 4. So again, it's top minus bottom. So I got 2, 4 to the 3/2 minus 2 times 1 to the 3/2. So when we go through this, you'll see here that we will wind up, this will actually wind up being 16 minus 2, and we will get an area here of 14 for our area under this part of the curve. All right, let's try one that has trig, because the same thing can be done. All right, so you got to know your trig integrals. So I gave you an easy one here to start. So the integral for secant squared is tangent. So I got tangent of x, and I'm going from 0 to pi over 4. So still doing top minus bottom. I got the tangent of pi over 4 minus the tangent of 0. All right, so if you remember your unit circle here, pi over 4 was 45 degrees. Tangent had radical 2 over 2, comma radical 2 over 2, and that's cosine and that's sine, but tangent there is going to be 1 because you got y over x there. So this has a value of 1, and the tangent of 0, here was 0, and you got 1 comma 0, 1 over x there. This is 1 minus 0, so we actually get an area of 1 for this one. Okay, so there's some great examples of the fundamental theorem of calculus. I wanted to show you another one right here. It says find the area bounded by y equals 2x squared minus 3x plus 2. The x-axis is 0 and 2. This is just a fancy way of writing out the integral. So really all this is the integral from 0 to 2. That's where these come in right here, 0 to 2. The x-axis, which just means we're in the first quadrant, okay? And here's your function of 2x squared minus 3x plus 2. So that's just in words. And we just do the same thing here. We do our power rule. So this will be 2/3 x cubed minus 3/2 x squared plus 2x. And this is going from 0 to 2. And now we do top minus bottom. So I got 2/3, 2 cubed minus 3/2, 2 squared plus 2 times 2. We're going to take that whole number, subtract it by plugging in the bottom. And what's nice is you can see here that's going to be 0, that's going to be 0, that's going to be 0. So I'm not even going to waste time there. That's going to be 0. So after all of that, that whole thing, once you plug that in your calculator, simplify that, you're going to get 10/3 for your area. Now the last thing in this section, as that ends the fundamental theorem of calculus, part 1 pretty much, is the average value of a function. The average value, okay, is pretty much like the mean value theorem for integrals. You're trying to find an average height. So the definition is pretty much this right here, as you can see, is if f is integrable on the closed interval from A to B, then the average value or the height of f is the following. So you got your fundamental theorem of calculus right here. This is your regular fundamental theorem of calculus. You just got a fraction that's in front of it. Okay, so this is the number one thing, though, people always forget, is that fraction that's in front. You got to make sure when you're asked to do an average value, you do 1 over b minus a, and that just comes from your bounds of integration right here. Okay, so I got one right here. Find the average value of the following. So I like to make sure that I always put in front 1 over, and again, there's your a, there's your b, so I'm going to have 4 minus 1, so I'm going to have 1/3 that goes in front of the integral, going from 1 to 4 of 3x squared minus 2x dx. So I do my power rule. So I have x cubed minus x squared, and I'm doing this from 1 to 4. So again, remember, it's top minus bottom. So I'm going to have 4 cubed minus 4 squared minus 1 cubed minus 1 squared. So as you can see, this is going to be 0 on the right over here, okay? And we're going to wind up with this part right here as being 48. Now, what you can't forget is this part right here. That 1/3 has to be multiplied at the end. Number one mistake. So we're going to get 1/3 of 48, and we will wind up with 16, and that winds up being our average height of that curve. So average value problem right there. Okay, so hopefully that helps. Got a few examples there, fundamental theorem of calculus. If you're new to the site, make sure you subscribe, and appreciate you tuning in.